Ready for another deep dive? Today, we're going to explore something that's everywhere, but we rarely think about it. Symmetry.
It's one of those things, right? Like, it's all around us, but we kind of take it for granted.
Exactly. So, to guide our deep dive, we have this really interesting textbook, Does It Look the Same?
Catchy title.
Right. But don't worry, this isn't about dry lectures or anything. The book uses these playful examples, and it really makes you see symmetry in a whole new light.
I totally agree. It brings up a lot of aha moments, which is what we love, right?
Absolutely. So where do they start? Well, like with anything else, the book dives into the basics first. Mirror halves, and that line of symmetry.
Ah, the classic fold down the middle test. But, it's more than just drawing a line.
True. The book even has these two shapes, both split by a line, but only one is actually symmetrical.
And that's the key. It's about having those two sides be perfect reflections of each other. Just having the line isn't enough. It has to fold perfectly.
It's like when you fold a piece of paper with ink on it and then unfold it to reveal that intricate design.
Exactly. And then they connect that to nature. Butterflies, flowers, all these things we find beautiful often have that perfect mirror symmetry.
Speaking of beauty, the book talks about how our brains are hardwired to like symmetrical faces.
Yeah, there's actually a fascinating evolutionary reason for that. We tend to see symmetrical faces as a sign of good health.
Really? So like our ancestors were subconsciously picking mates based on symmetry.
In a way, yes. A symmetrical face could have meant better genes, which would be important for survival, and passing those genes on.
Wow, that's wild. So symmetry is about more than just aesthetics. It's tied to our biology, too.
Exactly. But hold on, it gets even more interesting. The book then goes on to explain how a perfectly symmetrical shape can actually appear asymmetrical depending on the colors used inside.
Wait, what? How is that possible?
Well, they show these two shapes. Both are symmetrical in terms of their outline, but the way they're colored inside makes all the difference.
So even though we know the shape is symmetrical, our brains get tricked by the colors.
It seems like it. It all comes down to how our brains process visual information. We're wired to quickly make sense of what we see, and sometimes that means taking shortcuts.
Like focusing on the outline rather than the details inside.
Precisely. And that's where things can get a little wonky because our brains love to find patterns, even when they might not be there.
That's incredible. It's like those optical illusions where you see one thing, but then, wait a minute.
And it shows just how complex our visual system really is. We're not just passively seeing the world, we're actively interpreting it, making sense of shapes, colors, and patterns.
It's mind-blowing when you think about it. And speaking of mind-bending, the textbook then introduces this guy, Venki, and his shapes.
Yeah, Venki's shapes. This is where the book gets really interactive.
Right. They give us all these shapes, and it's like, okay, figure out where to put a mirror to create this specific reflection.
And some of them are tricky. I'll admit, I had to stare at a few for a while.
Me too.
Yeah.
You really have to think about it. Try to mentally fold the shape and the reflection together in your head.
Exactly. And that's what makes it such a good exercise. You're not just looking at shapes, you're actively engaging with them, figuring out how they relate to each other in space.
It's like those puzzles, the ones where you fold and cut a piece of paper and then you have to guess what the unfolded shape will look like.
Yes, it's all about spatial reasoning. But then the book takes a sharp turn and tells this funny story about a king and his locker.
A king with a locker. Okay, I'm intrigued.
Well, this king, he kept getting robbed because he could never remember if he'd locked his locker or not.
What? Was the lock broken or something?
Nope. It was the handle. It was perfectly symmetrical.
So it looked the same whether it was locked or unlocked.
Precisely. Turning it halfway looked exactly the same as a full turn, so he could never remember if he'd turned it enough to actually lock it.
That's both clever and kind of frustrating. Poor king. But what did he do?
Well, his daughter, she came up with a simple but elegant solution. She suggested adding a tiny dot to one side of the handle.
Breaking the symmetry?
Exactly. Just that little dot was enough to give the king that visual cue he needed to know if it was locked or not.
It's amazing how such a small change can make a big difference.
It really is. And it just goes to show sometimes a little bit of asymmetry can be a good thing.
Right. It's like those little design details we see everywhere, on products or tool. They might seem random, but they're actually strategically placed to make them easier to use.
Exactly. Form and function all tie together. But getting back to shapes, the book introduces another type of symmetry, rotational symmetry.
Okay, so we're talking about shapes that look the same after being turned, right? Like a spinning top.
More like shapes that look the same after a part of a turn. The book starts with simple ones, like the letter N.
Oh, right. If you flip it upside down, it still looks like an N.
Exactly. Or a zero. You turn it halfway, same thing, still a zero. And the book goes way beyond just letters and numbers, showing how it works with all sorts of shapes.
And to get hands-on with it, there's a whole section on making a toy windmill.
It's brilliant. You spin the windmill, and boom, you see those rotations, half turns, making it look the same again and again.
Like those fancy cakes, right? With the layers that repeat all the way around.
Perfect example. Each slice is basically a rotation of the whole cake. But hold on, it gets wilder. They don't just stop at half turns, they go into quarter turns, even 1/6 turns.
Now that's getting tough to picture.
Imagine a pizza. 6 equal slices. Each slice is a 1/6 turn of the whole pizza.
Okay, now I'm getting hungry, but yeah, I see what you mean. Though those are tougher to spot than a simple line of symmetry, aren't they?
Definitely. But once you start looking, they're everywhere. Snowflakes, flower petals, even how the seeds are arranged in a sunflower.
Wow, it's like this hidden order all around us just waiting to be noticed.
Exactly. And this deep dive has shown us symmetry isn't just some visual quirk. It's woven into how we understand the world, from our biology to our sense of beauty.
It really makes you appreciate the elegance of it all. And who knew you could learn so much from just one textbook about shapes?
Right. It goes to show sometimes the most familiar things hold the most fascinating secrets.
So, to our listeners, keep your eyes peeled. The next time you're out and about, take a moment to appreciate the symmetry around you. You might be surprised at what you've been missing all along. And hey, don't be afraid to embrace a little asymmetry now and then, too. It's what makes life interesting. Until next time, happy exploring.